Good evening. I'm Nikita. I'm a PhD student from IIT Madras, and today we'll be discussing about the week 8 lectures. So this is your week 8 live class for the course Basic Environmental Engineering and Pollution Abatement. Before we start, I want to know if you have any questions from this week's lectures or from previous week's lectures. So if you have any questions, you let me know now. So, uh, okay, so we'll proceed with the live class. So what we'll be doing is, I'll be going through a series of topics, so selected topics from the week 8 lectures. And after that, we'll be proceeding for the questions and answer sessions, where I'll give you some MCQs, multiple choice questions. So I'll be asking you, and you will have to give me the answers. And I'll also explain the answers, like the reason behind the answers. Okay, so if there are no further questions, then let's proceed. Sorry, there is been a delay, so there is some technical glitch which I'm trying to fix now. So give me a few minutes.
So is my screen visible now?
Yes, ma'am.
Okay. Yeah, so let's begin. So this is week 9, and so what is sludge? We've discussed about this previously, especially in secondary treatment. What is sludge? So sludge is the semi-solid slurry, especially the after biological treatment. Whatever organics are eliminated, I mean the dead bacterial cells, some organics, all of this will constitute sludge in secondary treatment. In primary treatment, whatever I mean solids have been settled after coagulation, flocculation, so that will be called as sludge in primary water treatment. So in either case, it refers to the semi-solid slurry that comes from water or wastewater treatment, or even from certain industrial processes. Like certain industrial processes may produce chemical precipitates, so that also can be called as sludge. Okay, so there are different types of sludge. Something which is generated during the primary treatment is called primary sludge. That which is generated from secondary treatment is called secondary sludge. And there can also be mixed sludge, which comes from both primary and secondary processes combined together. And then there is tertiary sludge, which comes from tertiary treatment processes or advanced processes. Like some advanced oxidation processes, like Fenton, especially, can generate a lot of iron sludge. So that also contributes to this. And then coming to anaerobic treatment, sludge is also generated in septic tanks. So the solids in sludge can be of two types. It can either be inorganic or fixed, and organic and volatile. So the two types are inorganic or fixed solids, and the second type is organic or volatile. Now, in order to characterize the sludge, we need to find the specific gravity. So what is specific gravity? What is specific gravity?
The weight of sludge.
Is it just the weight of the sludge?
Weight of water content with sludge.
No, but that is water content, right? Water or moisture content, rather. Why do we call it specific gravity? What is this term, specific gravity?
Weight of the solids, and we are considering 9.8 meter per second square as gravitational force acting
No, but that is the gravitational
on
constant.
the solids.
See, specific gravity is the ratio of densities. So It is the ratio of density of solid to density of water. So if your solid density is somewhere around 2500 kilogram per meter cube, and what is the density of water?
1000.
Yeah. So this ratio will be 2.5. So this is just an example that I'm giving. So similarly, we will have such specific gravity values for sludge as well. So in order to calculate that, there is a formula. So this is 1 divided by fixed solids by total solids divided by 2.5 plus volatile solids by total solids divided by 1. So 2.5 here is the specific gravity of solid particles, like that are actually solid, like sand or gravel or something. And 1 is the specific gravity of water.
Is this a fixed value for this solids 2.5 value?
Generally, we assume that for soil it is usually 2.5. So that is an assumption for sand especially. But for sludge it can be less. It can be around 1.5 or 1.6. So here we are calculating fixed solids by total solids divided by 2.5. So 2.5 is assumed to be the specific gravity of the fixed solids.
Okay.
So, like I said, going back to this formula. So specific gravity is rho s by rho w. So here the rho s is the density. The density of the solid particles, and rho w is the density of water. So rho s equals mass of the solid divided by the volume of solids. Now here the total volume of solids will be, it will be the sum of volume of fixed solids plus volume of volatile solids. Now, if we take the density of the fixed solid, so density of fixed solid will be mass of fixed solid divided by the volume of fixed solids. Now, if we interchange this, volume of fixed solids will be mass of fixed solids divided by the density of fixed solids. And similarly, the volume of volatile solids will be the mass of volatile solids divided by the density of volatile solids. So now if we rewrite this, this is actually a ratio. Mass of volume of fixed solids is the ratio of mass of volatile solids divided by the mass of total solids divided by 2.5. Now 2.5 here is the density of the fixed solid, and similarly we can write mass of volatile solids divided by the mass of total solids divided by 1, where 1 is assumed to be the density of the volatile solids. So substituting all these, we get specific gravity equal to 1 by fixed by total solids divided by 2.5 plus volatile by total solids divided by 1. Okay, so coming to sludge management. So why do we need sludge management? What does sludge contain? Why should we manage it?
I mean, we can recover energy. I mean, it is a sustainable step.
Yeah.
So we generally use sludge digesters for energy recovery.
Okay. Is that the only? What if we don't? Our sludge does not contain enough organics, or it does not contain enough volatile substances. What then?
Then it can be like disposed to landfills.
Yeah, but that's what I'm asking. Why do we need to dispose it?
I mean, if we will not that sludge dispose, then it will create a load on treatment units. So it is a necessary requirement.
No, anyway, we are separating. I'm not asking why we are separating sludge. I'm asking why we need to dispose or handle the separated sludge. What happens if we don't do that? What if we just throw the sludge on land? Why do we need to properly?
It will contaminate soil.
Yeah.
Because some inorganics are present. It may also have lead and arsenic metals that may contaminate the soil.
Yeah. So sludge contains a lot of organic waste and a lot of inorganic waste. So this inorganic waste will have metals, heavy metals, some like persistent pollutants, and even pathogens. Pathogens are organisms that can cause diseases in human beings. And second, like you said, we need sludge management for energy recovery. So we can dewater the sludge and use it for making biogas. So how do we do sludge management or sludge treatment? How do we do sludge management?
First, we separate them, making separate. Using dewatering process.
Yeah, but dewatering comes later.
We use the sludge drying beds.
Yeah, but what you're saying is all in the later stage. So first, immediately what we have to do is we have to concentrate the sludge because it has a lot of water content. So we need to make sure the solids are more than water. So that is why we concentrate the sludge. And this can be done by gravity thickening. And flotation. So flotation is just we use air to make sure the sludge particles float to the top and then we collect them. So then comes digestion. So because mostly sludge still contains a lot of organics, it is important to digest the sludge before going for further processes. So first, after concentration, we will go for anaerobic digestion. So this is the most commonly used digestion process. And there are other methods also like using a facultative lagoon. So I've told you what is facultative. Can you recall what it means?
Facultative means having both anaerobic and aerobic.
Yeah. So it has both aerobic and anaerobic bacteria. So both kind of bacteria will digest the sludge. And then there is aerobic digestion also, but it can be used only for small volumes. Because the organic load is high. So anaerobic digestion will be a better suited process. And then we go
Ma'am,
for
what are
sludge
lagoons? I
conditioning.
mean, they are.
Huh?
Ma'am, what are lagoons? I mean, just like ponds.
Lagoons, yeah, they are mostly like ponds. Like ponds are very big, but lagoons are very, slightly smaller. And we allow the sludge to digest in a facultative condition where at the top we will have aerobic condition and at the bottom layer we will have anaerobic condition. So both conditions will be there. Both kind of bacteria will be there. So it will be give and take between the two processes. And then we go for sludge conditioning. So here chemicals are added which will make sure the water does not retain in the sludge. And this improves the dewatering capacity also. So then we also go for heat treatment. So both chemical addition and heat treatment will ensure the dewatering capacity, and it will also ensure that flocks are formed properly. Now comes dewatering. So for dewatering, we can use a variety of equipments like a centrifuge or filters, drying beds. We cannot directly apply the sludge into centrifuge and drying beds because the sludge is very wet. So it won't be feasible. We will need a lot of time and a lot of area also. So that is why we take all these steps first. We concentrate, digest, condition, and then we bring the semi-solids, actual semi-solids for dewatering. So
I think centrifugal pumps require dry content, so that's why.
yeah,
Because then it will malfunction if there is a water content if enter.
no, actually, it's not like it should not. It's not that it should be completely dry. It can be a little wet also. So centrifuge mainly presses the solids together so that water gets released from the pressing process. So that's what centrifuge press and filters drying beds.
Okay.
And then there is oxidation. So by oxidation, we can go for incineration. So incineration, because now the water content is very minimal, so that is why we are going for incineration. Or we can even have wet air oxidation. So incineration produces a lot of gases. So again, that has to be treated. So even though it is a very good process, but it is also heat generating, but it also produces a lot of gases which need to be collected and treated separately. So once all these processes have been done, finally we get to dispose the sludge. And how do we do that? By landfilling.
Landfills. Yes. Or maybe creating underground
Or open dumping.
open digging.
So this is
Open
more
dump.
common in India. And then as fertilizers. So because of the rich organic content, sludge can be used as a very good fertilizer and also soil conditioner. Now, for use to be used as a soil conditioner, we have to ensure that the heavy metal content is zero. Like there should be no heavy metals or any toxic substances in the sludge. Only then it can be used as a soil conditioner. And we can also go for composting. So composting is a biological process to convert
And that's bioremediation comes under this disposal method.
bioremediation.
Yes.
What is bioremediation? Bioremediation we saw for wastewater treatment. So where we used organisms, living organisms like plants for treating the waste.
But the sludge is also a waste. Why don't we treat with this method?
Can you tell me how this can be done? Because see, we were talking about bioremediation for water which is polluted with some substances. So we can pass the water through the soil so that the plants can take it up. But your sludge is already a solid, so your plant cannot digest it. So if it has if it is in a soluble form, okay, maybe it can take it up. But this is already in a very concentrated form. It is a solid, and moreover, we've seen that how pollutants get concentrated when they are coming out as sludge.
Yes.
So this won't be feasible, and we cannot go for bioremediation, especially for solids. That can be done for water.
Okay.
Into minerals. Yeah, so then during composting, the organics are converted into compost. So the compost can then be used for growing plants. So the advantages of composting is the volume gets reduced. And we can also have a better nutrient control. But the disadvantages are it is an expensive process, and we also have aeration requirement. So we'll be looking at composting in detail when we go for the solid waste management portion. But right now, I'll just explain in brief. So during composting, we aerate we collect the waste and then we segregate it, and then whatever fine particles are there, we allow it to decompose. And during the decomposition process, we need to aerate frequently so that the microbes can grow and proliferate, and then they can degrade the organic waste. So then it is allowed to, the temperature is allowed to rise. And once the temperature has risen, it means that the reaction is taking place vigorously. So then after 14 days to 1 month, we will get compost. So there are some factors that affect the composting process. First one is the oxygen content. Second one is the microbes. So the kind of microbes present will determine what kind of products we will get and how long it will take for the composting process to take place. And the third one is the carbon to nitrogen ratio. So ideally the carbon to nitrogen ratio should be 25 to 30. And the moisture content. So if there is no moisture content, then the bacteria will not be able to grow. So it cannot, composting cannot happen in a completely dry condition. So we need some kind of, some amount of moisture. And then the particle size. So if the particles are very big, then their decomposition will take time. And then the temperature. So at if the temperature where the composting is taking place, if it is a cold country or there is cold climate, then the reaction will be slower compared to places where the temperature or the ambient temperature is higher. And then the last one is time. So there are different types of composting. Conventional or windrow composting. So here we will have piles of material. So it will be in the shape of a windrow. So this is how it looks from the side. From the front, it will look something like this. So these windrows will be are actual piles of waste that have to be turned periodically. So when we turn, what happens is there is aeration will take place. So the material inside and under will come up and it will get contact with air. So in this in a pile, it is important to have a high porosity because otherwise the oxygen will not be able to penetrate. So that is why we sometimes add bulking agents. Like wood chips or leaves.
So what are these bulking agents, by the way?
So bulking agents are nothing but bigger particles which will create some porosity when they are mixed along with the waste. So they won't be, they'll also get degraded, but their main function is to ensure that there is air passage inside. So if all particles are very small and minute, then they will be densely packed together. So that will create anaerobic conditions. To avoid that, we are adding these substances. And then we can also add carbon and nitrogen rich waste to adjust the ratio. So we'll be looking at carbon nitrogen ratio and why we need to maintain in detail when we come to the solid waste portion. Now I'm not going to explain that. And then there is vermicomposting. What is vermicomposting?
Using earthworms.
Yeah. So worms are used, especially earthworms. And then there is the rotary drum. So this process is not conventional because a rotary drum is basically a drum or a cylinder. So this cylinder will have holes and it will be connected and it can be rotated. So when rotation happens, whatever waste is inside, it will get mixed up. So whatever waste is here, when rotated, it will come up. And during rotation, the aeration also will happen because holes are present. So sufficient ventilation is there. So oxygen will be able to enter and the mixing will ensure that the penetration is good. So this can be used in smaller places, for example, in individual homes. So kitchen waste or garden waste can be put into it and then it can be composted. So this requires less space and it is used for small scale composting. And then anaerobic digestion can also be done. So here in anaerobic digestion, as we already saw, anaerobic bacteria will break down the biological matter and this will happen in the absence of oxygen. So the products that are generated in anaerobic digestion include biogas, hydrogen, fertilizer or compost.
Methane.
Yeah, that comes in biogas. And reusable water. So during anaerobic digestion, water also comes out because that is also a product. When organic matter is broken down, it releases mostly methane, carbon dioxide, and water. Sometimes hydrogen can also be generated. Even sometimes alcohol can also be generated. So all of these can be recovered. And finally, some of the digested product can be used as manure. It is a very good fertilizer. So we'll be looking in detail about how anaerobic digestion happens. So first, the first step is preparing the waste for the digestion process. So preparation involves shredding, blending, and pH adjustment. So all this is done by adding the waste or organic feed. We can call it waste or organic feed, both are the same thing. And we have to add sufficient amount of water and chemicals. So depending on the desired pH, we can add chemicals and we can first go for shredding or cutting down the organic waste into smaller particles and then blending it all together and then adjusting the pH. So once all these pre-treatment processes are done, we go for anaerobic digestion. So during anaerobic digestion, this gas evolution will be there. So this gas mainly has methane, water, water vapor actually.
How much at how much temperature?
Sometimes it can go up to 60 or 80 degrees also. And then once the digestion is complete, we go for dewatering. So whatever solids are generated in the dewatering process, they will be disposed, but the liquid, whatever is remaining, will go for treatment. So based on the characteristics of the characteristics of the liquid, it will undergo treatment, and whatever sludge is there, so it can be either disposed or it can go for further treatment. And after treatment, it is discharged. So now we'll be looking at the steps that happen or take place during anaerobic digestion. The first step is hydrolysis. What is hydrolysis? What happens during hydrolysis?
Splitting of hydronium ions.
Are you sure?
I mean, in alcohol process, we generally use the hydrolysis, I think. Primary alcohols.
So hydrolysis is breaking down complex organics into simpler ones with the help of water. In the presence of water, and this is done by hydrolytic bacteria. So the enzymes in hydrolytic bacteria will break down complex organics Complex organics means carbohydrates, fats, and protein to simpler organics. So simpler organics means carbohydrates are converted into complex carbohydrates are converted into simple sugars, and fats are converted into fatty acids or peptides, and proteins.
Amino acids.
Yes. Once this is done, acidogenesis will happen. So, acidogenesis, as the name suggests, means acid production. So, fermentative bacteria will convert the simple organics which were generated here into short chain fatty acids. The next process is acetogenesis. So here acetic acid is produced, and this is done by hydrogen producing bacteria. So this will convert the short chain organics or short chain fatty acids into acetates plus hydrogen and carbon dioxide. Now the last process is methanogenesis. Can you guess what this means?
Generating methane.
Yes, methane production. So methanogenic bacteria converts the acetate to methane and carbon dioxide. Now, this methanogenic bacteria is known to be highly sensitive. So, this is one of the most important processes during anaerobic digestion because the bacteria is highly sensitive. Even a small change in pH, temperature, or operating conditions, even the type of organic matter, any small change can affect the methane production. So that is why this is sometimes the slowest step, or sometimes the most sensitive step, we can say. So this, if this is affected, then methane production will be slow.
How these bacteria are made methanogenic? I mean, are they biologically engineered?
Sometimes, but sometimes these bacteria themselves grow under these conditions. See, bacteria are very sensitive beings, so they can easily adapt to conditions. So it's like if something is toxic, then initially some bacteria will die, but some bacteria, because of their some bacteria will produce genes which are resistant to such toxic or what to say unlivable conditions. So they will develop resistance, and that's how they evolve actually. So it's very similar to how humans evolved and how other organisms evolved. So for other organisms, the process is very slow, but for bacteria, it's very quick. So if something is toxic to them, they immediately develop genes to counter those conditions. So that's how these bacteria will have learned to survive. So acetogenic bacteria, or be it hydrolytic bacteria, whatever it is. So if the conditions when they are not favorable, they change their functioning in such a way that they continue to live by performing either of these processes like hydrolysis or acetogenesis, and so on. So we take advantage of this ability of bacteria. So since bacteria are doing this naturally, so we don't have to interfere in their process. Instead, make it more suitable for them to continue doing what they do, and by that we get some products also, which is useful for us. So that's what happens. But sometimes they can be engineered also. Sometimes these bacteria, if they are not naturally occurring, then we can add them externally.
Okay, ma'am.
Okay, so then we can even write an equation, a stoichiometric equation actually. For anaerobic digestion. So assuming this is the organic compound CnHaOBNC plus. So I'll explain all these terms once I finish writing the equation. Okay, so this equation
It's a
will
very
give
big
us,
formula, man.
yeah. So we can use this equation to predict if an organic compound is getting degraded, then how much water do we need to add? So that is the second term here, and how much. After decomposition, how much methane is going to be produced, how much carbon dioxide is going to be produced, and how much organics are going to remain, and then how much ammonium is going to be produced, how much bicarbonates are going to be produced. So all this can be predicted using this equation. So this will give us a better idea. So here I've written some alphabets, so I'm going to write on what that means. So D is 4n plus A minus 2B minus 3C. And here N, A, B and C are nothing but the
Coefficient.
coefficients of carbon, hydrogen, oxygen and nitrogen. So like if you have a formula like C5H12O6N2, this is just an imaginary formula that I've written. So N will be 5, A will be 12, B will be 6 and C will be 2. So accordingly we can write, and then D will be this 4n plus A minus 2B minus 3C, and S will be the fraction of waste which is converted to cells. And E is the fraction of waste converted to methane. So here in this equation, this term C5H7O2N is the term used for a bacterial cell. So this equation will also tell us how much of the organic waste is getting converted to new bacterial cells. So that is what is represented. So that is what is represented by this term. So always S plus E will be equal to 1, because the same fraction, because these two are fractions of waste. So S is the fraction of waste which is getting converted into new cells. E is that which is getting converted to methane. So always the sum of these two will be equal to 1. So these two S and E will be given along with the question if asked. So you need not worry about it. So there are some factors which affect the yield of biogas. The first one is the amount of solids or the organic dry content in the feedstock. The feedstock is the inlet organics that we are going to put into the digester for the bacteria to convert into biogas. And if the feedstock is high on volatile fatty acids, then the pH is going to be high or low.
High.
How come? I just told you that volatile fatty acids are high. So will this increase or reduce the pH?
Oh yeah, I mean acidic. Yeah, it's low actually.
Yeah.
Yes.
So because of this, the pH will be reduced, and because of the reduction in pH, methanogenesis process will be slow. So this, like I said earlier, the methanogenic bacteria are highly sensitive to pH, temperature, etc. So if the pH becomes acidic, then methanogenesis will be slowed down. And then the second one is the carbon to nitrogen ratio, which should be 20 to 35. And then temperature. So temperature should be ideally more than 40 degrees, because we need thermophilic bacteria. So thermophilic bacteria are the one which convert the organic waste into biogas. So in order for them to survive, they are thermophilic, meaning they love high temperature. So that means we need to provide at least 40 degrees for their survival. So, and that will also improve the rate of reaction. So that is why it is important to maintain a higher temperature. And then pH. pH should be high. And then we have to give sufficient retention time. So we cannot just expect the process to be completed in a couple of days. We need to wait the required time, sometimes 10-15 days for the process to happen. Because it is an anaerobic process, it is usually slower compared to aerobic processes. The reaction rate is also quite slow. And then it also depends on the type of digester. And the kind of microbes that grow. Now coming to the kinetics of this anaerobic digestion process. So like I said previously, methanogenesis is considered the slowest step. So usually in a chemical reaction, the slowest step is also called the rate limiting step. What is a rate limiting step? A rate limiting step is something which will decide the rate of reaction. So if there are a series of reactions, 1, 2, 3, 4, and all of these are important for the process, like to convert organic waste into methane, for example. And if 1, 2, 3, all of them are happening very fast, and only 4 is slow, then the rate of reaction will depend entirely on how fast 4 is going to take place, because the other 3 are going to be they are fast already, so they they will not affect the rate of reaction that much compared to the last step. So that is why methanogenesis is the rate limiting step, or something which will limit the rate of reaction or affect the rate of reaction or slow down the rate of reaction. So that is methanogenesis. But if the cellulose content is high, now what is cellulose? Cellulose is again a complex organic matter which needs to be broken down, and we saw in the first step hydrolysis. So this is where the hydrolytic bacteria will break down the complex organics into simpler ones. So if we have a lot of complex organics like cellulose here, then what happens? The hydrolysis step will be taking a longer time. So that is going to be your slowest step. So usually, always in a reaction, the slowest step is the rate limiting step, because that is what decides the rate of reaction. So if the cellulose content is high, then the rate limiting step becomes the hydrolysis process. So rate limiting step is the one which determines the rate of reaction, and which is usually the slowest step in the reaction because all of the steps are fast. It's like you run a relay race. So the winning team will have, I mean, if there are 4 people in the relay race, the first 3 are running very fastly, but the 4th person or the last person is quite slow. Then the how much time it takes for that team to win will be determined by how fast the last person is running. So it's similar to that. And now we look at the type of digesters. The first one is the conventional digester. So a conventional digester, usually the rate is low and the mixing is done intermittently, meaning it is not continuous. So there is some interval and then mixing happens. And the retention time is at least 30 to 60 days. The second one is a high rate digester. So here the mixing is continuous. So as we mix, the rate of reaction will increase because more bacteria will come into contact with the organic substance. So the growth will be better and the digestion will also improve. And because the reaction is happening faster, your retention time will also be reduced because the rate of reaction is inversely proportional to the time of reaction. If your rate is high, then the time for the reaction to take place also will reduce. So the retention time in this case will be less than 15 days. And the third type is a 2-stage digester. So here, two different stages are there. The first stage is acidogenesis. And methanogenesis. So unlike the other reactors here, conditions will first be maintained for acidogenic process, and once acidogenesis is complete, then methanogenic bacteria will be allowed to grow. So this will create a better control because both processes will take place efficiently. So in a combined process, sometimes acidogenic bacteria will interfere with methanogenic bacteria. Conditions may not be suitable for methanogenic bacteria, which are okay for acidogenic or acetogenic bacteria. So likewise, there will be some issues. And this can be eliminated by using a 2-stage digester where methanogenesis is happening exclusively. So after acidogenesis, methanogenesis is taking place. So that is the advantage of this 2-stage process. So now we'll be looking at some industries.
Where does this COD digester comes under?
COD digester. See, COD digester is a step. So when you do COD analysis, we keep the sample in a digester. We put some acid and we allow the digestion to take place. So that is an entirely
Yes.
different thing. So that is a chemical process.
Yes, ma'am.
Yeah, so this we are talking about is anaerobic digestion, where anaerobic bacteria is used for converting organic waste into biogas using anaerobic digesters. So both are entirely different.
Yes, ma'am.
Yeah. So it's like comparing, digestion that is happening inside our stomach to anaerobic digestion. Both are entirely different.
Yes,
Context is
ma'am.
different. Yeah. Okay. So looking at sources of wastewater in the bagasse industry. So bagasse industry, basically it is a sugar producing industry where bagasse is a byproduct. So in this industry, the wastewater can be coming from cooling tower overflow. So we provide cooling towers. From this, the water may sometimes overflow, and this is collected separately. And then the wastewater coming from the various processes like sugarcane mills or the RO reject, or even from boilers. So the hot water used for boiling or maintaining the boilers at certain temperatures. So that is also a wastewater. And the water that is used for the cleaning the evaporator tube. Now all these three will be separated into different streams to improve the efficiency of the treatment process, because some waste may have high organic content like that coming from mills, RO or boilers. They may have a higher organic content compared to that coming from cooling towers or evaporator tubes. Actually, the water coming from the evaporator tube will have a high COD. So that's why these three streams are separately treated. So mainly, bagasse industry will have sulfur. So this sulfur is removed in the during using the following process.
Hello, ma'am. Your voice is not coming.
Is it clear now? Am I audible? Am I audible now? Are you able to see my screen? Okay, so in the first stage, calcium hydroxide will be added. So this will precipitate uh, sulfur as CaSO4 as gypsum. Am I audible now? And in the second stage, the polyelectrolytes are added to convert Am I audible now?
Yes, ma'am.
Soluble sulfate to insoluble. Now, other than this, there can also be air pollution and noise pollution. So, how do we control those? For air and noise pollution control, we can first we look at the sources of these. So, noise pollution sources are from shredders that are used to cut the sugarcane, and steam venting,
ID fan.
from steam leaks. Sometimes when steam is flowing at a very high speed and there is a leak, so that can
ID
generate a
fan.
lot of noise.
Noise from ID fan.
And washing evaporators, sources of air pollution. So producing bagasse will emit a lot of sulfur dioxide, carbon monoxide, nitrous oxide, and carbon dioxide. So we need proper air pollution control and silencers for controlling the noise. So for silencers, we generally go for vegetation or having plants around the place, which will act as barriers, which will absorb noise. So yeah. So with this, we have come to the end of this lecture. So do you have any questions from today's class?
No, ma'am.
So if there are no questions, then I'll proceed with the Q&A. So the first question is, what percentage of methane is produced from acetic acid, from the acetic acid route? So methanogenesis can happen through the acetic acid route or through the maybe like, let me just go back. Yeah. So methanogenesis is mostly happening through the acetate or the acetogenic route. The other route can be through hydrolysis. So directly from hydrolysis, the CO2 can be produced. So that is also there. So these two routes are there. So the question is, what is the percentage of methane that is produced during the using the acetogenesis route. So the options are 28%, 72%, 52%, and 76%. Which will be the correct answer?
No idea, ma'am.
So the
28%.
correct answer is B. 72% of methane is produced from the acetic acid route. The rest is produced from the hydrogen route. So hydrogen is produced along with methane, where hydrogen production will dominate and methane will be lesser. So that is why it contributes to lesser amount of methane. Second question. Which bacteria will convert cellulose to glucose? So cellulose is a type of substrate, or it is a type of complex organic matter. So that will be broken down into glucose by which bacteria? Options are acidogenic bacteria, second one is acetogenic bacteria, then hydrolytic bacteria or methanogenic bacteria. So can you, if
Ma'am,
you
option
recall
is
all
hydrolytic.
the steps of anaerobic digestion, maybe you will be able to answer this question.
Ma'am, hydrolytic will be the answer. Option C. Ma'am, third option, hydrolytic.
Your voice is not audible.
Ma'am, option C, hydrolytic.
Yeah. So during hydrolysis, the bacteria will break down complex organics into simpler ones. So that is what is happening here. Cellulose is converted to glucose by hydrolytic bacteria. But the process is very slow. So in such cases, the hydrolysis becomes the rate limiting steps. The third question is, So the question is, which of the following is not a control variable in wet air oxidation process?
Ma'am, the answer is A, retention time. Ma'am, answer is B, retention time.
So the correct answer is option B. Next one. So the question is, which of the following is a nitrogen-rich feedstock for composting? Options are wood chips, cardboard, grass clippings, and waste paper. So you've got to think which will have which will have a lower carbon to nitrogen ratio to answer this question.
Ma'am, answer is wood chips.
So wood chips, they are rich in carbon, so they are not an option. Second one is cardboard. Cardboard is also rich in carbon. Grass clippings, yeah, they will have a sufficient nitrogen content because they are plants, and waste paper will also have lesser nitrogen content. So the correct answer is option C. Next one is so the question is, which of the following is an example of acetogenic bacteria? So the options are A. Clostridia, then B. Lactobacillus, and C. Streptococcus, and D. Salmonella.
Ma'am, what is option A?
Your voice is not audible. Clostridia. So the correct answer is option A, Clostridia, because rest, as you know, Lactobacillus is the bacteria which converts lactic acid to lactase. Lactose to lactase, and then Streptococcus and Salmonella are common pathogens. So eliminating them. So the correct answer is option A, Clostridia. Okay, so with this, we have come to the end of today's class. So if you have any questions, then let me know, or we can conclude the session.
Ma'am, can you please send all the questions of regarding this NPTEL
Your
exam?
voice is not audible. Can you type your question? Yeah, I'll be sending all the notes that we discussed so far in all the classes. So I have them week-wise, so I'll upload them on the drive so that you can go back and check and practice those questions. So I'll not be uploading just the questions alone. So I'll be uploading all the notes so that if you have any questions or doubts in any of the subjects or any of the topics that we discussed, you can refer to those notes. Thank you.